FAANG interviews repeatedly test one's skill, recognizing patterns. Sliding window is one of their favorites, and today I'll make it crystal clear. Before learning sliding window, you only need 3 simple concepts.
First, subarray. Subarray is just a contiguous chunk of an array. For example, in this array, 2 3 is subarray, but 1 3 is not, because it's not contiguous. In sliding window problems, we simply call a subarray a window. So whenever I say window, think subarray. Second, window bounds. A window is defined by 2 indices, left and right. Left is where the window starts, right is where the window ends. If left is 1 and right is 3, the window is subarray from index 1 to 3. So the entire sliding window pattern is really just about moving these 2 pointers. Third point, valid-invalid windows. Most sliding window problems define a rule that makes a window valid. For example, sum of the window is less than k, or window has at most 1 0, or product of window is less than k. These rules are called constraint metrics. If the current window breaks the rule, it's invalid. Now the sliding window idea. Here's the magic. We expand the window by moving right forward, adding elements. If the window becomes invalid, we shrink it by moving left, removing elements. So the window grows until rule breaks, then shrinks until the rule is satisfied again. And throughout the entire algorithm, the window always slides to the right. Quick example. Given an array of positive integers nums and integer k, find the length of the longest subarray whose sum is less than or equal to k. Let's use an integer cur that tracks the sum of the current window. Since the problem wants subarrays whose sum is less than or equal to k, we want to maintain cur to be less than or equal to k. Let's look at an example where nums is this and k is 8. The window starts empty. We can grow it to this while maintaining the constraint. However, after adding the 7, the window's sum becomes too large. We need to tighten the window until the sum is below 8 again, which doesn't happen until the window looks like this. When we try to add the next element, our window becomes again too large, and we need to remove 7, which means we have 4. We can now grow the window until it looks like this, but adding the next element makes the sum too large. We remove elements from the left until it fits the constraint again, which happens at this. The longest subarray we found was this, which means the answer is 4. So expand when you can, shrink when you must, and track answer as you go. That's a sliding window pattern in a nutshell. Here's the general template for it. Why it's fast? Even though there are 2 loops, sliding window runs in O of n, because right moves n times, left moves n times, and each element is added and removed once. Total 2n operations in the worst case. So to wrap up, remember the terminologies. Window is subarray. Left and right pointers define the window. Window is either valid or invalid. Expand right, shrink left. Whenever a problem asks shortest or longest subarrays with some constraints, this is the pattern you use.